Hey guys, this is a continuation of the numerical methods in MATLAB. In this video, we're going to do the composite Simpson's 1/3 method. Now this one is more difficult than the rectangular and the trapezoidal methods previously discussed, but I'll do my best to try to make it make some sense. So what we have here, same as the last video, because we're going to do a comparison in the next video. We have the X matrix that goes from 0 to 30 in increments of 2. That's what this notation is. And we have the R matrix that corresponds to the X matrix. H, which is the step size, in this case it's 2. N is just the length of the X matrix. Now the f of A is R of 1, which is 15. F of B is R of N, which in this case is 10.6. Now, that's easy, right? Now, the confusing part, what are these things? What are these things? That's what I'm going to try to explain. So we're having, in this one it's taking 4 multiplied by the sum of the I values that start at I equals 2 and then go in increments of 2 all the way to n. So how does that work? Well, I'll try to explain it. So we have st4, which is my Simpson's third 4 value, which is this value right here. And then st2, which is this value right here. It's just my notation. So for the first for loop, we have I equals 2, which is this. And it's going to go up in increments of 2, just like this. So 2, 4, 6, 8, blah, blah, all the way to n. And it's going to just sum them up. This is going to sum up the f of xi right here. So r of I of 2, r of I of 4, r of I of 6, etc., all the way down to r of n. So initially the st4 is 0, and it's going to take 4 times 13.5, which is r of 2, which is the I of 2. And then it's going to take whatever 13.5 times 4 is and add it to 10.8 times 4. And it's going to take the sum of those two, and it's going to add it to 9 times 4. And it's going to take those three values and add it to 8 times 4. So it just does that all the way to n. And the similar thing with the 2 value here. So the st2 is what I called it. So Simpson's third 2 value. So it's starting out at I equals 3, and it's going up in increments of 2. So I equals 3, increments of 2, to n minus 1. So we have the third value, r of 3, is 11.9 times 2. And this is initially 0 as well. The st2 is initially 0. So we have the 11.9 times 2. And then it adds 11.9 times 2 plus 9.7 times 2. And then adds those two. And then it adds the 8.4 times 2 to those previous ones all the way to n minus 1. So it's going to do it all the way to 9.6. And then here at the bottom we have the Simpson's third here. So h over 3, which is this, times r of 1, which is the f of a, so that's the 15, plus our st4 value, which is this, plus our st2 value, which is this, plus our r of n, which is 10.6. It's the f of b here. And it multiplies the h of 3 times each one of those. Now what happens when we run this? We get this. And you can see it's a little off compared to the rectangular and trapezoidal methods. And we're going to do a full comparison in the next video, the Simpson's 3/8 method. And I'll see you there.